Next, we can talk about isotopes. So we're going to title this page Isotopes. And as a reminder, an isotope is defined as two or more atoms that have the same number of protons but different numbers of neutrons. So to illustrate this, let's draw two different atoms. And a good example for isotopes is carbon. So we're going to show one atom of something called carbon dash, and then another atom of carbon dash 14. And if you recall from the vocabulary, this number represents something called the mass number. That's the protons plus neutrons. So we're going to draw an arrow to show that this represents mass number. And then in parentheses, protons plus neutrons. And then the same thing applies to this 14. The mass number of this one is 14, which means that its protons plus neutrons is 14, while this one on the left is 12. So when we drew our neutral atom and when we drew our ions, we drew out every single proton and neutron. But now, since our atoms are getting a little bit more complicated, we're going to simplify things. And instead of writing the number of positive signs, we're just going to write this as, well, a number. Instead of drawing out each and every one, we're just going to write it as a basic number. So carbon has an atomic number of 6, which means that it has 6 protons. So we're going to just put 6p plus. And we're going to do that instead of drawing 6 positive signs. And then normally, carbon has 6 neutrons. And we're going to put those in the nucleus. And then around the nucleus, we're going to draw our 2 dotted circles. And then let's make this a neutral atom. So since it has 6 protons, we're also going to give it 6 electrons. But remember the rule that says we can only put 2 on the first dotted circle. So we're going to use our short notation of putting 2e negative for 2 electrons, 2e negative. We want 6 in total, so we've already the first circle. How many do we need to put in the second circle if we want 6? That's right. 2 plus 4 is equal to 6, so this one is 4 electrons. So we put 2 electrons in the first circle, 4 electrons in the second circle. 4 plus 2 is 6, just like we want. So under this diagram, I'm going to write protons, 6, neutrons, also 6, and then electrons, also 6. Now let's come over to the right and draw a diagram of carbon 14. Just like carbon-12, it's also going to have 6 protons. But carbon-14 is interesting. It does not have 6 neutrons. It has 8 neutrons. So we're going to put those in the nucleus. Once again, draw our 2 dotted circles around the nucleus. Once again, let's make this a neutral atom. So we need 6 electrons in total. 2 go in the first, 4 go in the second. Once again, we're going to draw the number of protons, neutrons, and electrons. So we've got 6 protons. Neutrons, we said that we have 8. And then electrons, 2 plus 4 is 6. And now this is where we can begin to compare our numbers. So the number of protons, 6 and 6, are the same. But if you look at the number of neutrons, 6 and 8, these are very different. So now we have an illustration to show 2 different atoms that have the same number of protons, but very different numbers of neutrons. That makes these 2 elements, carbon-12 and carbon-14, isotopes of each other.